So here's an introduction of on the topic of circular motion. In previous lessons, we learned about uh, objects moving in uniform motion, such as in a straight line. For example, a dot represents the position of an object. So let's say this is the original position. After a certain amount of time, so let's say maybe in every second, it traveled this certain distance. Okay. And then the same thing right here. And then another distance, which is equal in terms of change in position. So if we figure out the distance from here to here, if we can look at the number of slots for each of the graphing paper line, you have 3 sections, 3 sections, 3 sections. So if I want to figure out the speed, okay, or the rate of how fast it moves, let's say that this is distance number 1. Okay, so this is our distance, which is our x. Okay, so let's figure out this x. So this is our position x, and this is our position x. Well, let's say this is our x naught, since that is the original position x. So for us to figure out the total distance, okay, or we want to figure out the speed, and then we need to know the total distance first. So if each x right here, okay, is the position, let's say this is our position 1, position 2, and position 3, as we have learned it in the previous lessons. And just to figure out the displacement is simply delta x, which is x minus x naught, or depending on which location you want to figure out the distance. Now for time, since time is always what we call a continuum, okay, so this is your time at position, or the original position, which is t naught. This is t, and then t. So t1, t2, and t3. And here, when we were working on straight lines, okay, for uniform motion, that the delta t, or the change in time, which is like time minus the initial time, is basically what we call the period. Okay, so period. So all we have to do is to figure out the speed, and speed is delta x, which is our change in position, which is our distance or displacement, divided by the change in time, which is also known as period. So delta x over delta t. Now what if, okay, that straight line, okay, straight line is not straight anymore? Or what I mean by it is that it is still traveling at the same position, same rate of change in position, but it's not moving at a straight line anymore. It's not moving at a straight line, but instead it is moving around in a circular pattern. So let me just use the green pen. Let's say you start at t equals t sub 0 at this point. But instead of going in a straight line, the object started to change position, not in a straight line, but instead something is preventing it from going in a straight line. Now it is going in circles. Okay. Oops. It's going in circles. That's my mistake. So now it's moving in circles at still the same equal distance. Still equal distance. And then if I use what we call compass and try to measure that same distance, equidistance we call it. Hopefully I can draw using this compass. So now I've noticed that I did travel and follow the path, because something's preventing me, or the object is prevented to move in a straight line. It forms what we call a circular pattern, like what we've been learning today. Circular pattern. Now, using the same concept that we know, how do we figure out the speed? Okay, the speed of the object as it goes around in circles. Speed is delta x over delta t. Okay. So delta x over delta t. Now, in order to figure out the speed, it should be one cycle. Okay, so one cycle. So it only rotates once. So you want to figure out the rotation once. Okay, once. However, from the experiment that you have witnessed, the object is not rotating once, but instead it was rotating several times. And that rotation, the number of rotation, we can derive something. Okay. So rotation, let's say that is one rotation per second. So rotation per second. So rotation per second, also known as RPS. Okay, RPS, rotation per second. Let me just zoom in so you could see. So rotation per second. Now that we already have a background of what we're doing right here, so rotation per second. So rotation per second is actually also known as your frequency. Okay, so rotation per second is the frequency. Based on the definition of frequency, it is how often do you repeat a certain action per unit time of per second. So frequency. So rotation per second is also your frequency, or that is in hertz. And how do you get the period? So period, or uppercase T, is simply equivalent to the inverse of the frequency. So if we go back to this equation right here, T is period. So from the lesson we learned in the beginning of the school year, we've been saying delta T is actually period. It's not time, period, but sometimes we just associate it to time because it's actually a measurement of time, or we use the same measurement of time, which is seconds. So delta T is period, but since it's going in circles, so now I know that my period is basically T, uppercase T. So one information solved already. Now, if I start from this point and I will follow around it using this yarn or string, and so I can basically, measure the distance that it traveled. Okay, I can basically measure the distance that this object traveled in a straight line. Okay, so you can go around and then measure it using a ruler or a meter stick, depending on how far the object or the body traveled. So in this case, in your math class, you learned something to figure out that distance that the object traveled around a circle. If this is the center of the circle, okay, the definition of circumference is basically the distance around the circle, or so the measurement around the circle. So I just mentioned the name, and that is your circumference. So if I have my radius r, in order to figure out the circumference is the linear distance around. So let me just write a very simple definition. Okay. So this is our first step for frequency. Now how about for the displacement, delta x? Circumference is the linear displacement, okay, displacement around a circle. Okay, circumference around the circle with respect to a given to a known radius. Okay, so radius is represented by the letter R. So radius, letter R, right here. Radius, letter R. Okay. Radius, letter R. So how do you figure out the speed? The speed of that object that is going around the circle. Okay, it's the same process as going in a straight line, but this time you just have to change the way you calculate the distance. Instead of just taking the change in position, this time you can actually determine the total displacement. Okay, the total displacement around the circle. And we all know that circumference is calculated or determined using the equation 2 pi r. Okay, so 2 pi r. So now we can plug in those values here. Circumference is actually your displacement, delta x. And period t is this is our delta time t, which is our period. So by plugging in all those information together, the speed or the linear speed, it's actually a straight line like this. And this one right here. So those are the speed. Okay, speed, 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 or to be exact, it is the velocity instead of calling it speed, because this time it is actually changing direction, but you have the same rate. It's changing direction, but you have the same rate. 5 meters per second, 5 meters per second, now it's downward. 5 meters per second, now it's to the left. 5 meters per second, now upward. 5 meters per second to the right. So you're changing direction, so it is not a speed, but instead it's a linear velocity. However, the speed, which is the rate, is the same. So now we can safely change this from speed to velocity to be correct. The displacement is not a straight line, so now we're going to call this as our 2 pi multiplied by the radius, which is equivalent to your linear speed. Linear distance around the circle divided by period, which is time t. Okay. Where? Okay. T is 1 over frequency, or we can just say the time can also be for shortcut, and that is 1 divided by the revolutions per second or rotation per second, RPS. So if your rotation is in minutes, you have to convert it first to seconds. So here's a brief explanation on how to derive the equation from a from straight line, or from an object moving in a straight line, comparing it to an object going around in circle, and what is that what we call linear velocity, which is our v over here. So v represents linear velocity because it represents what if the object is going in a straight line. Okay. So if the object is going in a straight line, that velocity is equivalent to this.